Okay, it looks like 6.2. We're getting there. So let's see how far I can get. The power rules are there. Hopefully you know when you're multiplying, you just add the power. So this is e to the 8th, because 3 plus 5 is 8. When you're dividing, we're subtracting the powers. But you do reduce this fraction 11 over 22, which is 1/2. And if there's 9 e's on the top and 10 e's on the bottom, 8, 9, 10. Hopefully you understand that when you reduce variables, you're really canceling the one on the top and one on the bottom until you have one or however many are remaining. And then if there's one left on the bottom, then that e ends up on the bottom. And 10 minus 9 is 1, but since there are 10 e's on the bottom, we need to have that 1 left over on the bottom. For number 3, we've got a power on parentheses. When you have a power in parentheses, everything in the parentheses goes to that power. So 5 to the 4th power, and then e to the 7x to the 4th power. 5 to the 4th power is 5 times 5 times 5 times 5, and then 625. And e to the 7x to the 4th power, when you have a power of a power, you multiply the powers. So you get e to the 28x. Okay, now we have to decide if it's growth or decay. And in the last section, you looked at the base. And this base is 2.718, which is bigger than 1, but it's always 2.718 because we're working with the exponential function. But there is a way to make it decay, and that's to make the power negative. So since the power is positive, we have growth. So if you're choosing growth, that's growth, that's growth. This is decay, and that's decay because it goes down from left to right. This goes up, and this one goes up. So let's see if we can figure out which equation this is. We've got, if x is 0, we have e to the 3 times 0, which is 0, which is 1. So we're looking for the point 0, 1. That's 0, 1. This one's 0, 1/2. Not that one. It's this one. Okay. Of course, you could just graph it, right? And you can look at the graph of it. Now that this power is negative, so we know it's decay. Since this is growth, it's not this equation. This one's growth, it's not this equation. So these two are the two decay ones. Let's see. If we have x is 0, then y is 2 times e to the 0. Remember, e to the 0 is 1. So we're looking for the point 0, 2. In the decay, 0, 2 is that point. 0, 2 is that point, and it's not this one because it doesn't go through it. So that is your choice. And again, you could graph it on your calculator. So we have to make decisions about tritium and sodium-22. Sodium-22, we can look at stuff and know stuff about it by looking at the graph. And tritium uses this formula. Y equals the starting mult is 10 times E. The rate of decay is negative 0.0562. And then you multiply by T. And time is recorded in years. The starting amount for the sodium-22 is 15, because that's how much there is at time equals 0. And which one starts with a greater amount? This one starts with 15, that one starts with 10. So sodium -22 has more. And then which has a greater amount after 10 years? After 10 years, sodium has like 1 or 1.5 or so. And after 10 years, we can just plug in 10 for T. And we can use a calculator to find out what number that is. Times E to the negative 0.0562 times 10. And that leaves us 5.7 after 10 years. Which is more than the 1.5. So the tritium has more. Okay? Definition of a log with base B. So are we in the new section, 6.3? Yep, and we're talking about logs. And logs, remember, have a base, and the corresponding position in an exponential is the base of the exponential. Logs equal a power. So this is a power. And its corresponding position is that position, the power on the exponential. And then the argument inside of the log, the number you're taking the log of, has a corresponding position also, and it's right there. Okay. And they are inverse functions. Rewrite this in exponential form. So we know that 2 is a power, and that 3 is a base. And when you write something in exponential form, you have a base to a power equals a number. All you have to do is plug the right numbers in. Well, if the power is 2, it goes there. The base is 3, it goes there. And that leaves 9 for that spot. And make sure you take a second to make sure that 3 squared is 9. Since it is, it's correct. Now we're going to rewrite this as a log. Remember, power equals log. So 2 equals a log. And there's 2 numbers you have to fill in the log. The base, which is 6, and the number you're evaluating the log of, and that's 36. Evaluate this. You can grab your calculator to do it, or if you know what a log is, we can just peel that 3. A log is the power that you put on 3 to get 81, and that number is 4. You can, of course, graph it on your calculator. Not graph it, just plug it into your calculator. Under math, log base, you put a 3 down there, and 81 up there. We can figure out that that number is 4. Oh, wait. I skipped number 4. Same thing with this one. Let's go log base 5 of 1 over 625. We'll get negative 4. Math, log base 5 of 1 divided by 625. Negative 4. Okay, should be quick and easy. Log of 6 on the calculator, press the log button. That means log base 10 of 6 is 0.778. Round to 3 decimal places. 0.778. Okay, number 5. When the base of the exponential is the same as the base of the log, they undo each other. So whatever this number is, that's what's left. And the same thing with this one. Remember, natural log of 4 is the same as log base e of 4. So this says e to the log base e of 4. And the base of the exponential is the same number as the base of the log. Everything disappears and we're just left with that 4. Of course, on that one, we can just put it into the calculator, e to the natural log of 4, and see that that's just 4. Find the inverse. What they're saying is rewrite it as an exponential. So the inverse of this is x equals log base 2 of y. And then rewriting it as an exponential, remember, power equals log. So x is the power on the base of 2, which equals y. So the inverse is y equals 2 to the x power. For this one, rewrite it as a log, right? So we're going to write this function down, switching the x to a y and a y to an x. Solve for the exponential. So we're solving for 5 to the y by adding 9. And 5 to the y power is x plus 9. Now rewrite it as an x as a log. Power equals log. So y equals a log. And the base of the log is 5. We're evaluating x plus 9. So that is the inverse function. So we have to graph this, choose the right one. So I'll graph it quickly and choose the correct one. We've got a log base, so math, log base 1/3, 1 divided by 3 of x. And we'll just graph this. I'll zoom 6, because I just had a different window before. And it's the one that comes down. And if we look at the table, we can choose some points too. We're looking for 1, 0, 3, -1, and 9, -2. It comes down, not up. 1, 0, 3, -1, 9, -2. These both, the second points were not on. 3, -1, 9, -2. That is the correct one. Okay, so I think I'm done with 6.3. Okay.